The magnetic pole sprint. Earth's magnetic North Pole is racing towards Siberia at unprecedented speeds that have shattered every prediction about planetary magnetic behavior. Since 2000, the pole has been moving 40 miles per year, nearly 4 times faster than any recorded rate in human history. Climate scientists are baffled because this acceleration defies every model of how Earth's magnetic field should behave, forcing emergency updates to navigation systems worldwide. The World Magnetic Model, used for global navigation systems including GPS satellites, aircraft autopilots, and military targeting systems, has required emergency updates multiple times because the pole's movement is outpacing all calculations. The model, typically updated every 5 years, has needed revisions every 12-18 months as the magnetic field changes in ways that violate established electromagnetic theory. Dr. William Brown from the British Geological Survey stated that the acceleration represents behavior we've never observed in the geological record, spanning hundreds of thousands of years. Magnetic field measurements show that the North Pole's movement has increased from 9 miles per year in the 1990s to over 40 miles per year today, with recent measurements suggesting speeds approaching 50 miles per year with no signs of slowing. Most disturbing is that the South Magnetic Pole is simultaneously accelerating in the opposite direction at nearly identical rates, suggesting that Earth's entire magnetic field is undergoing a fundamental reorganization. This dual acceleration has never been recorded in geological history and contradicts models of how planetary magnetic fields evolve over time, scales ranging from years to millennia. Satellite measurements from the European Space Agency's Swarm constellation reveal that the magnetic field strength is decreasing by 5% per decade in the South Atlantic anomaly, while inexplicably strengthening by similar amounts over Siberia. These chaotic variations create magnetic anomalies that disrupt wildlife migration patterns, interfere with technological systems, and generate navigation errors that exceed safety margins for commercial aviation. The magnetic field's rapid reorganization is creating unprecedented challenges for wildlife that depend on magnetic navigation. Arctic terns, which navigate using magnetic cues during their 44,000-mile annual migration, are arriving at destinations hundreds of miles from their traditional locations. Whale strandings have increased 300% in regions experiencing rapid magnetic field changes, suggesting that marine mammals are becoming disoriented by the shifting magnetic landscape. The European Space Agency's Swarm satellite mission has detected mysterious magnetic pulses emanating from Earth's core that occur in patterns too regular to be natural. These signals, dubbed magnetic jerks, happen every 6 to 8 months and appear to originate from depths of 1,800 miles below the surface, where conventional climate science assumed conditions were stable and unchanging. Recent analysis has revealed that the magnetic pole acceleration is correlating with seismic activity in unexpected ways. Earthquake patterns are shifting as the magnetic field changes, with increased seismic activity occurring along lines connecting regions of rapid magnetic change. This implies connections between electromagnetic and geological systems that challenge fundamental understanding of how different planetary systems interact. The implications extend far beyond navigation problems. Earth's magnetic field protects the planet from solar radiation and cosmic rays, and its rapid reorganization is creating gaps in protection that allow increased radiation penetration. This additional radiation is affecting atmospheric chemistry in ways that climate models cannot account for, potentially altering ozone concentration and atmospheric electrical properties. Commercial airlines have reported navigation system failures in regions where magnetic field changes exceed 10% annually. The Federal Aviation Administration has issued advisories for pilots flying routes over northern Canada and Siberia, where magnetic compass readings can vary by up to 20 degrees from GPS coordinates, creating dangerous discrepancies between different navigation systems. The atmospheric river invasion. Atmospheric rivers, narrow corridors of water vapor in the sky, typically 252 to 375 miles wide, are appearing in regions where they physically shouldn't exist, according to climate science. These rivers in the sky are forming over landlocked areas thousands of miles from oceans, carrying impossible amounts of moisture that violate the fundamental laws of atmospheric physics and hydrodynamics. Dr. Marty Ralph from UC San Diego's Center for Western Weather and Water Extremes documented atmospheric rivers over the Central Sahara Desert in 2023, transporting water vapor equivalent to 20 times the flow of the Mississippi River. The phenomenon is impossible because atmospheric rivers require oceanic moisture sources and specific wind patterns that don't exist over desert regions. Yet, satellite imagery clearly shows these massive moisture streams persisting over arid landscapes. Satellite imagery from NOAA's GOES-16 weather satellite shows these anomalous atmospheric rivers maintaining their structure for thousands of miles over dry land without dissipating. Traditional meteorology dictates that such moisture streams should evaporate rapidly over hot, arid surfaces due to the large vapor pressure deficit. Yet these rivers persist and even strengthen as they travel inland, gaining moisture from unknown sources. The water vapor content of these desert atmospheric rivers exceeds what should be possible given local evaporation rates and humidity levels. Atmospheric physicists using radiosondes and satellite moisture profiling cannot explain where the moisture originates or how it maintains coherence without continuous oceanic input. The moisture content often exceeds 250% of what the atmosphere should be able to hold at measured temperatures and pressures. Most puzzling is that these impossible atmospheric rivers are producing precipitation patterns that don't match any known weather formation processes. Desert regions are receiving rainfall amounts of 4 to 6 inches in 24-hour periods, quantities that would typically require storm systems powered by oceanic energy sources that are thousands of miles away, and drawing from water bodies with surface areas exceeding 100,000 square miles. Temperature measurements within these anomalous atmospheric rivers show thermal properties that contradict established atmospheric thermodynamics. The water vapor remains at temperatures that should cause immediate condensation, according to the Clausius-Clapeyron equation, yet it maintains gaseous form until reaching specific geographic locations where it precipitates suddenly and completely within hours. Meteorological radar reveals that these atmospheric rivers contain electrical activity patterns unlike any known weather phenomena. The electromagnetic signatures suggest energy sources that aren't accounted for in atmospheric models, implying unknown processes are creating and maintaining these impossible moisture streams. The electrical activity resembles technological signatures more than natural atmospheric electricity. Atmospheric pressure measurements within these anomalous rivers show pressure gradients that violate hydrostatic equilibrium principles. The pressure patterns suggest that these moisture streams are being artificially maintained or generated through mechanisms that atmospheric physics cannot currently explain, requiring energy inputs that exceed available solar and convective sources. The timing of these anomalous atmospheric rivers correlates with solar activity cycles in ways that atmospheric science cannot explain. Increased solar flare activity appears to trigger the formation of these impossible moisture streams within 24 to 48 hours, suggesting electromagnetic influences on water vapor behavior that challenge fundamental meteorological assumptions about how atmospheric moisture responds to external forces. Chemical analysis of precipitation from these desert atmospheric rivers reveals isotopic signatures that don't match any known water sources. The oxygen and hydrogen isotope ratios indicate water that has never been part of normal oceanic evaporation cycles, suggesting these atmospheric rivers are accessing water vapor from sources that conventional hydrology hasn't identified. The ocean current rebellion. The Gulf Stream, one of Earth's most stable ocean currents carrying 150 times the flow of the Amazon River, began exhibiting chaotic behavior in 2019 that violates every principle of oceanographic science. Instead of following its established path along the North American coast, segments of the current are spontaneously reversing direction, creating eddies the size of states that appear and disappear without explanation or warning. Dr. Stefan Rahmstorff from the Potsdam Institute for Climate Impact Research documented that sections of the Gulf Stream have completely reversed their flow direction for periods lasting 3 to over 6 months. This behavior is impossible according to oceanographic models because the current is driven by consistent pressure gradients, temperature differences, and Coriolis forces that haven't changed, yet flow measurements show directional reversals exceeding 180 degrees. Ocean temperature measurements reveal that reverse sections of the Gulf Stream are somehow maintaining their thermal characteristics despite flowing in the wrong direction. Warm water continues to move northward at temperatures of 20 and 25 degrees Celsius, even when current flow measurements show southward movement, violating basic principles of thermal dynamics and energy conservation in fluid systems. The current reversals are creating massive ocean eddies spanning 400 kilometers that rotate in directions opposite to what Coriolis forces should produce in the northern hemisphere. These counter-rotating systems are maintaining their structure for 4 to 8 months, while exchanging water with the main current in patterns that defy fluid dynamics and conservation of angular momentum. Most disturbing is that these current anomalies are affecting marine ecosystems in impossible ways. Tropical fish species are appearing in regions north of Cape Cod, where water temperature and chemistry should make their survival impossible, suggesting that ocean conditions are no longer following predictable patterns, or that unknown transport mechanisms are moving marine life against natural barriers. Satellite altimetry from Jason-3 and Sentinel-6 missions shows that sea surface heights in Gulf Stream regions are fluctuating independently of current flow, indicating that gravitational or pressure forces are operating differently than oceanographic theory predicts. These elevation changes occur without corresponding wind patterns, tidal influences, or atmospheric pressure systems that might explain the variations. Deep ocean measurements using Argo floats reveal that the current reversals extend to depths of 3,000 meters, where oceanographers assumed conditions were stable and isolated from surface influences. Temperature and salinity profiles at these depths are changing in synchronization with surface current anomalies, implying unknown forces are affecting the entire water column simultaneously. Acoustic Doppler. Current profiler measurements show that reversed current segments are moving at velocities that exceed what the available pressure gradients should be able to generate. The flow speeds suggest energy sources that aren't accounted for in oceanographic models, requiring driving forces that operate independently of wind stress, thermal gradients, and gravitational potential energy. The timing of Gulf Stream reversals correlates with electromagnetic disturbances detected by magnetosphere monitoring satellites in ways that oceanographic science cannot explain. Solar storm activity appears to trigger current changes within 12-36 hours, suggesting that electromagnetic fields are influencing ocean circulation through mechanisms that challenge established understanding of ocean-atmosphere-space interactions. Marine biology studies reveal that plankton communities are responding to current reversals before flow changes are detectable by instruments, suggesting that ocean ecosystems are sensing environmental changes through mechanisms more sensitive than current oceanographic monitoring technology. This biological early warning system implies that ocean conditions are changing in ways that conventional measurements cannot detect. The permafrost paradox. Arctic permafrost is simultaneously melting and expanding in different regions, creating temperature patterns that violate thermodynamic laws and conservation of energy principles. Scientists have documented permafrost areas that are cooling and expanding, while adjacent regions melt rapidly, generating temperature gradients that should be impossible to maintain without external energy sources exceeding solar input. Dr. Vladimir Romanovsky from the University of Alaska, Fairbanks measured permafrost temperatures that increased and decreased simultaneously at different depths within the same borehole location. Temperature sensors show surface permafrost warming at rates of 2 to 3 degrees per year, while deeper layers cool at similar rates, creating thermal inversions that contradict heat transfer principles and geothermal gradient theory. Ground-penetrating radar surveys reveal permafrost boundaries that shift daily in patterns unrelated to surface temperature changes, solar radiation cycles, or soil thermal properties. These frozen-thawed boundaries move vertically and horizontally by distances of 10 to 50 meters within 24-hour periods in ways that suggest unknown energy sources are selectively heating and cooling different soil regions with surgical precision. Most puzzling is that some permafrost regions are releasing methane at rates exceeding 100 times normal levels, while others are absorbing atmospheric gases, including CO2 and nitrous oxide, creating localized atmospheric chemistry that varies dramatically over distances of less than 100 meters. These gas exchange patterns don't correlate with soil temperature, biological activity levels, or organic matter content. Chemical analysis of permafrost cores shows organic matter that is both decomposing rapidly and becoming more stable simultaneously within the same samples. Carbon dating reveals impossible results where surface materials appear 5,000, 10,000 years older than deeper layers, violating geological stratification principles and radioactive decay laws that govern carbon-14 dating accuracy. Thermal imaging from Landsat and MODIS satellites shows permafrost regions with surface temperatures that don't match subsurface measurements from ground-based sensors. Ground truth data consistently contradicts satellite thermal readings by 10 to 25 degrees, suggesting that permafrost is exhibiting thermal properties that infrared sensors cannot accurately detect, or that unknown processes are masking actual surface temperatures. The rate of permafrost changes is accelerating in patterns that don't correlate with air temperature trends, precipitation patterns, or solar radiation cycles. Some regions are experiencing temperature changes of 10 to 15 degrees within days, rates that soil thermal dynamics cannot support given known heat transfer coefficients, thermal conductivity values, and soil heat capacity measurements. Seismic monitoring using sensitive accelerometers reveals that permafrost changes are accompanied by micro-earthquakes in patterns that suggest structural modifications are occurring faster than thermal expansion or contraction could produce. The mechanical properties of frozen ground are changing in ways that challenge materials' science understanding of ice-soil composite behavior. Electromagnetic surveys of permafrost regions show electrical conductivity patterns that vary independently of temperature and moisture content. The electrical properties suggest that permafrost is undergoing phase changes that don't follow normal ice-water transitions, implying unknown mechanisms are altering the fundamental structure of frozen soil systems. The ionospheric chaos. Earth's ionosphere, the electrically charged layer of atmosphere, 5,400 miles above the surface, is exhibiting electrical behavior that contradicts atmospheric physics and electromagnetic theory. Regions of the ionosphere are spontaneously generating electrical charges thousands of times stronger than solar radiation could produce, creating electromagnetic anomalies that disrupt global communications and satellite operations. Dr. Jeffrey Forbes from the University of Colorado documented ionospheric electrical activity that exceeds input from solar radiation by factors of 100 to 1,000% during periods of normal solar activity. The excess electrical energy has no identifiable source and appears to be generated within the ionosphere itself through unknown processes that violate conservation of energy principles. Radio wave propagation measurements using very low-frequency transmitters show that ionospheric electrical density patterns are shifting in ways that violate established atmospheric electrical theory. Communication satellites report signal distortions, phase shifts, and amplitude variations that don't correlate with solar activity, geomagnetic indices, or known atmospheric disturbances. High-frequency radar systems, including AARP and ESCAT, reveal ionospheric plasma moving in organized patterns that resemble technological rather than natural phenomena. These plasma formations maintain geometric structures, triangular, rectangular, and hexagonal patterns that persist for hours despite atmospheric turbulence that should disperse them within minutes according to fluid dynamics principles. Temperature measurements using incoherent scatter radar show ionospheric layers heating and cooling independently of solar input cycles and seasonal variations. Some regions maintain elevated temperatures of 2,000–3,000 K during periods of reduced solar activity, suggesting internal heat sources that atmospheric science cannot identify or explain through known chemical or electrical processes. The electrical properties of ionospheric plasma are changing in ways that affect Earth's global electrical circuit, altering the potential difference between the ionosphere and ground from the normal 250,000 volts to values exceeding 500,000 volts. Lightning patterns worldwide are shifting as the ionosphere's electrical characteristics evolve, creating feedback loops between atmospheric layers that weren't recognized in climate models. Satellite measurements from the Defense Meteorological Satellite Program detect electromagnetic pulses emanating from the ionosphere that propagate downward toward Earth's surface. These signals have characteristics similar to artificial radio transmissions, specific frequencies, modulation patterns, and timing sequences, but originate from regions where no human technology operates. GPS signal analysis reveals that ionospheric disturbances are creating position errors exceeding 10 meters in regions where atmospheric models predict accuracy within 1 to 2 meters. The ionospheric effects on satellite navigation are following patterns that suggest coordinated rather than random electromagnetic interference. The timing of ionospheric anomalies correlates with geological activity in patterns that suggest electromagnetic coupling between Earth's surface and upper atmosphere through mechanisms unknown to atmospheric physics. Earthquake activity appears to trigger ionospheric disturbances within 2 to 6 hours, implying energy transfer mechanisms that challenge geophysical understanding of how different Earth systems interact. Plasma density measurements show ionospheric regions where electron concentrations exceed what solar ultraviolet radiation can produce, even during solar maximum conditions. The excess ionization requires energy sources equivalent to multiple solar flares occurring simultaneously, yet no such solar activity is detected by space weather monitoring systems. The gravity anomaly zones. Gravitational measurements across Earth's surface reveal localized areas where gravity is fluctuating in patterns that violate general relativity and Newton's law of universal gravitation. These gravity anomaly zones show gravitational acceleration, values that change daily by amounts that would require massive underground mass movements without corresponding geological activity or seismic detection. Dr. Carla Breitenberg from the University of Trieste documented gravitational measurements using Lacoste and Romberg gravimeters that vary by amounts exceeding instrumental error margins by factors of 10^50 at locations where no geological changes are occurring. Gravity values are fluctuating by 50 to 100 milligaules within 24-hour periods, variations that would require underground mass movements of billions of tons that aren't being detected by seismic monitoring networks. Precision gravimeters at multiple locations worldwide are recording synchronized gravity variations that occur simultaneously across continental distances, spanning 5,000, 10,000 kilometers. These coordinated changes are impossible, according to gravitational theory, because local gravity should only respond to local mass distributions within radii of 100 to 200 kilometers. Yet the correlated variations suggest global influences. Satellite gravity measurements from the GRACE follow-on mission show gravitational anomalies that appear and disappear over periods of days to weeks, without corresponding changes in surface or subsurface mass distribution. These short-term variations don't correlate with known geological processes, hydrological cycles, or atmospheric pressure changes that might affect regional mass distribution. Most disturbing is that gravity anomaly zones appear to influence local weather patterns in ways that challenge atmospheric physics principles. Regions experiencing gravitational fluctuations consistently develop unusual atmospheric pressure systems, temperature inversions, and wind patterns that don't follow normal meteorological relationships between pressure gradients and air movement. The gravitational anomalies are affecting precision timing systems in ways that suggest space-time curvature is changing at local scales beyond what general relativity predicts for measured gravitational changes. Atomic clocks in gravity anomaly zones show time dilation effects that exceed theoretical calculations by 20 to 40%, indicating that local gravitational fields are stronger than direct measurements suggest. Ocean tide measurements in coastal gravity anomaly zones show tidal patterns that don't match gravitational calculations based on lunar and solar positions from ephemeris data. The discrepancies suggest that local gravitational fields are being influenced by sources other than celestial mechanics, requiring additional gravitational influences equivalent to planetary-sized masses. Underground gravitational surveys using borehole gravimeters reveal mass distributions that don't match geological mapping from seismic surveys and core samples. Density measurements show underground structures that appear to change position or composition in ways that violate conservation of mass principles and geological formation processes. Gravimetric studies of gravity anomaly zones reveal that the fluctuations follow mathematical patterns, resembling technological signals rather than natural gravitational variations. The patterns include periodic oscillations, amplitude modulation, and frequency characteristics that suggest artificial rather than geological sources. Laboratory experiments using torsion-balanced gravimeters show that gravity anomaly effects can be detected in controlled environments, suggesting that the gravitational fluctuations represent actual space-time curvature changes rather than instrumental artifacts or environmental interference from electromagnetic sources. The atmospheric electrical storm. Earth's global electrical circuit is generating lightning patterns that contradict atmospheric electrical theory and violate the fundamental principles of charge separation and electrical discharge. Lightning is occurring in atmospheric conditions where electrical charge accumulation should be impossible, creating electrical storms in clear skies without the cloud formations required for conventional charge separation mechanisms. Dr. Earl Williams from MIT's Lincoln Laboratory documented lightning strikes originating from cloudless skies during periods of low atmospheric humidity below 30% relative humidity. These clear air lightning events produce electrical discharges with energy levels of 1 to 5 billion joules, comparable to conventional thunderstorms, despite the absence of charge-generating mechanisms like ice crystal collisions or convective updrafts. Electromagnetic field measurements using electric field mills and magnetic loop antennas show that atmospheric electrical activity is increasing independently of weather patterns, precipitation rates, and convective available potential energy. Lightning frequency is rising by 15–25% annually in regions experiencing decreased precipitation, violating the established relationship between moisture availability and electrical storm formation. Radio frequency monitoring using lightning detection networks reveals that atmospheric electrical discharges are producing signals with characteristics unlike natural lightning. These anomalous signals have regular patterns, specific frequency signatures in the 8 to 30 kHz range, and timing sequences that suggest non-random electrical processes are occurring in the atmosphere. Global lightning detection networks, including the Worldwide Lightning Location Network, show coordinated electrical activity occurring simultaneously across multiple continents, separated by 10,000 plus kilometers. These synchronized discharges happen without corresponding weather systems and appear to be driven by electromagnetic influences rather than atmospheric dynamics or meteorological forcing. The electrical storms are producing effects on Earth's surface that exceed what atmospheric electricity should be capable of generating, according to electromagnetic theory. Ground current measurements show electrical flows of 10 to the 100 amperes that persist for hours after lightning activity ceases, indicating that atmospheric electrical energy is being stored or channeled through unknown mechanisms. Atmospheric electrical changes are correlating with ionospheric disturbances in ways that suggest electromagnetic coupling between atmospheric layers through mechanisms unknown to atmospheric electricity research. Lightning activity appears to be responding to upper atmospheric electrical changes rather than being driven by surface weather conditions or tropospheric convection. Chemical analysis of air samples during anomalous electrical storms reveals atmospheric composition, changes that don't match known lightning chemistry or photochemical reactions. The electrical discharges are producing molecular transformations, including ozone creation and nitrogen fixation, that require energy levels exceeding measured lightning electrical output by factors of 5 to 10. Ball lightning observations during clear air electrical storms show plasma formations that persist for minutes, rather than the seconds typical of conventional ball lightning. These extended plasma phenomena maintain coherent structure and movement patterns that challenge plasma physics' understanding of how atmospheric electrical discharges can maintain organization. Atmospheric electrical measurements show that the global electrical circuit is operating at voltages 50 to 100% higher than historical baselines, suggesting that unknown electrical sources are energizing the atmosphere beyond what thunderstorm activity and solar influences can account for through established atmospheric electrical mechanisms. The magnetic field flip-flop. Regional magnetic field measurements show areas where Earth's magnetic field is rapidly switching polarity on timescales of hours to days, rather than the geological timescales of thousands of years predicted by geomagnetic theory. These localized magnetic reversals are creating navigation hazards and affecting wildlife behavior in ways that challenge fundamental understanding of planetary magnetism and electromagnetic field stability. Dr. Monika Korte from the GFZ German Research Center for Geosciences documented magnetic field reversals occurring over areas spanning 500 to 1,000 square kilometers within periods of 24-48 hours. These rapid polarity changes contradict magnetic field theory that predicts gradual changes over geological time, scales of 1,000–10,000 years, based on core magnetic field dynamics and electrical conductivity of Earth's interior. Magnetic declination measurements using precision magnetometers show compass readings that vary by 180 degrees between morning and evening measurements at specific locations. These daily magnetic reversals are occurring without corresponding changes in solar activity, geomagnetic storms, or local geological conditions that might affect magnetic fields through known electromagnetic induction mechanisms. Wildlife tracking studies using GPS collars and satellite telemetry reveal that migratory animals are becoming disoriented in regions experiencing magnetic field instability. Birds using magnetic navigation during long-distance migrations are exhibiting flight patterns that deviate by 200 to 500 kilometers from traditional routes, while marine animals like sea turtles are stranding at unprecedented rates. Magnetic field strength measurements using proton precession magnetometers show variations that exceed what planetary magnetic field models predict is possible given Earth's core magnetic field. Strength and geometry. Local magnetic intensity is fluctuating by 5,000–15,000 nanotesla within hours, variations that would require core magnetic field changes affecting the entire planet. Archaeological magnetic dating of recent materials is producing impossible results in magnetic anomaly zones. Magnetic orientation data from materials with known historical dates are showing magnetic field directions that don't match paleomagnetic records or geomagnetic field models, suggesting that local magnetic fields are operating independently of the global geomagnetic field. Satellite magnetic field measurements from the Swarm constellation reveal that the rapid magnetic reversals are occurring simultaneously at multiple locations worldwide with precise timing coordination. The coordination of these magnetic anomalies suggests they are being driven by electromagnetic influences rather than random geological processes or core magnetic field fluctuations. The underground electrical current monitoring using magnetotelluric surveys shows that magnetic field reversals are accompanied by electrical flows that don't follow normal geomagnetic induction patterns described by Faraday's law. These electrical currents appear to be causing, rather than resulting from, the magnetic field changes, violating established electromagnetic theory. Geomagnetic observatory data shows that magnetic field reversals create disturbances in Earth's magnetosphere that extend into space, affecting satellite operations and radio communications in ways that suggest the local magnetic anomalies are influencing planetary-scale electromagnetic phenomena. The carbon cycle breakdown. Atmospheric carbon dioxide measurements are showing patterns that violate the established carbon cycle, with CO2 levels fluctuating in ways that don't correlate with known emission sources, natural absorption mechanisms, or seasonal vegetation cycles. These variations are occurring too rapidly for biological or oceanic carbon processes to explain through photosynthesis, respiration, or oceanic gas exchange. Dr. Peter Tanz from NOAA's Earth System Research Laboratory documented atmospheric CO2 concentrations that increase and decrease by 1540 parts per million within periods of weeks, changes that exceed annual vegetation cycles by factors of 3 to 5. These rapid changes are impossible given the known response times of oceanic and biological carbon reservoirs, which operate on timescales of months to years. Regional CO2 measurements using tower-based analyzers show atmospheric carbon concentrations that vary dramatically over small geographic areas without corresponding differences in emission, sources, vegetation density, or land use patterns. These localized variations suggest carbon cycle processes that operate independently of biological and industrial activities, requiring unknown carbon sources or sinks. Isotopic analysis of atmospheric carbon using mass spectrometry reveals CO2 with isotopic signatures that don't match any known carbon sources, including fossil fuels, biomass burning, or biological respiration. Some atmospheric carbon appears to have carbon-13 to carbon-12 ratios that are impossible given current understanding of carbon geochemistry and biological carbon processing pathways. Ocean carbon measurements using autonomous monitoring buoys show marine CO2 levels that fluctuate independently of atmospheric concentrations, violating the principle of gas equilibrium between air and water interfaces described by Henry's law. Ocean carbon is increasing in regions where atmospheric CO2 is decreasing, suggesting unknown carbon transfer mechanisms. Soil carbon monitoring using automated chamber systems reveals underground carbon storage that changes faster than biological decomposition or plant growth rates can account for through known biogeochemical processes. Carbon content in soil samples varies by 20 to 50% within monthly periods, requiring biological activity rates that exceed measured microbial respiration and root turnover. Vegetation carbon uptake measurements using eddy covariance towers show plants absorbing or releasing carbon at rates that exceed their biological capabilities, determined by photosynthetic capacity and biomass measurements. Photosynthesis and respiration rates would need to be 100 times higher than measured to account for the observed carbon processing. Carbon cycle modeling using current atmospheric measurements produces results that contradict fundamental conservation laws and mass balance equations. The carbon budget calculation suggests that carbon is being created or destroyed through processes that aren't accounted for in biogeochemical theory, requiring unknown carbon sources equivalent to entire continental ecosystems. Atmospheric carbon measurements show diurnal variations that don't match solar radiation cycles or plant photosynthetic rhythms. CO2 concentrations are changing during nighttime hours when photosynthesis doesn't occur, suggesting non-biological carbon cycle processes that operate independently of solar energy input. The seismic pattern revolution. Earthquake patterns worldwide are reorganizing in ways that contradict tectonic plate theory and geological understanding of seismic activity. Earthquakes are occurring in stable continental regions, where geological surveys indicate no active fault systems exist, while traditional earthquake zones experience unusual periods of seismic quiet that violate statistical expectations based on historical activity. Dr. Seth Stein from Northwestern University documented significant earthquakes with magnitudes exceeding 6 points occurring in regions where geological surveys indicate no active fault systems exist and where the continental crust has been stable for millions of years. These impossible earthquakes are happening in areas like Central Australia, Eastern Canada, and the Central United States, where tectonic stress should be insufficient to generate major seismic events. Seismic activity timing is showing coordinated patterns across multiple continents that violate the principle of independent tectonic processes. Earthquakes on different continents are occurring in synchronized clusters within 24 to 48-hour periods, suggesting global rather than local geological influences that operate faster than tectonic stress propagation mechanisms. Deep earthquake monitoring using global seismic networks reveals seismic activity at depths exceeding 600 kilometers, where the geological structure should prevent earthquake occurrence. Earthquakes are being detected at depths where rock should be too hot and plastic to fracture in the brittle manner required for seismic events. Yet, clear P-wave and S-wave signatures indicate brittle failure mechanisms. The relationship between seismic activity and geological stress patterns is breaking down in ways that challenge fundamental understanding of rock mechanics and failure criteria. Earthquake magnitudes are exceeding what calculated stress levels should be capable of producing, suggesting that seismic energy is being amplified through unknown mechanisms. Earthquake prediction models based on historical seismic patterns and statistical forecasting are failing as earthquake activity moves to unexpected regions and follows timing patterns that don't match tectonic stress accumulation cycles. The predictable relationship between tectonic forces and earthquake occurrence is becoming increasingly unreliable, with forecast accuracy declining by 40 to 60%. Seismic wave propagation measurements using global seismometer arrays show velocity changes that suggest alterations in deep geological structure. Wave travel times are varying by amounts that indicate the planet's internal composition is changing faster than geological processes should allow, requiring material property changes that exceed known geological timescales. Earthquake aftershock patterns are following sequences that violate established principles of stress redistribution following major seismic events described by Omori's law. Aftershocks are occurring in patterns that suggest unknown forces are continuing to influence rock stress after primary earthquake events, creating stress distributions that don't match elastic rebound theory. Seismic tomography reveals that earthquake source regions are showing structural changes that occur between events, suggesting that the geological conditions that generate earthquakes are evolving rapidly rather than remaining static as tectonic theory assumes. These structural changes are happening faster than known geological processes can modify rock properties. Global earthquake energy budgets show that total seismic energy release is increasing beyond what tectonic plate motion rates can account for through elastic strain accumulation. The excess seismic energy suggests that additional energy sources are contributing to earthquake generation through mechanisms unknown to seismology. Conclusion: these 10 environmental anomalies represent more than scientific puzzles. They're evidence that Earth operates according to principles that current climate science cannot explain or predict. From magnetic poles racing toward each other at impossible speeds, to atmospheric rivers flowing over deserts, to gravity fluctuations that defy physics, our planet is exhibiting behaviors that challenge fundamental understanding of environmental systems. What unites these anomalies is their acceleration and coordination. Environmental changes that should occur over millennia are happening within months, while different planetary systems are exhibiting synchronized behaviors that suggest unknown connections between magnetic fields, ocean currents, atmospheric electricity, and seismic activity. The implications force us to reconsider whether climate science has accurately identified the forces governing Earth's systems. If magnetic fields can reverse rapidly, ocean currents can spontaneously change direction, and atmospheric rivers can appear without oceanic sources, then the stability that climate models assume may not exist. These discoveries prove that our planet operates according to rules that environmental science has yet to discover. The increasing frequency and magnitude of anomalies suggests Earth may be undergoing a fundamental transformation that exceeds conventional climate theory, involving system-wide reorganization rather than gradual change. The evidence suggests we live on a planet whose environmental behavior cannot be fully explained by current scientific understanding. These anomalies may be revealing fundamental properties of planetary systems that science has never recognized, forcing us to acknowledge that Earth is far stranger and more dynamic than climate research has prepared us to understand.